Friday, 8:30 a.m. Welcome to Advanced VPC Design and new Amazon VPC capabilities. I'm Matt Lewis. I'm a solution architect here at AWS.
I'm Alex Huidish. I'm a principal solutions architect at AWS as well.
So the idea of this session is we cover a lot of the new capabilities that we've released over the last 12 months for Amazon VPC. Not just VPC, but things around VPC. We'll start with a bit of a foundational kind of reset or a primer on VPC for folks who aren't familiar, and then we'll dive into a lot of the new stuff. Some housekeeping items. This is a 300 level session, so we're not going to dive too deep into a lot of the details, but there's going to be some stuff in there that's pretty technical. We also have this little photo icon. We have a lot of builds, so as you know, Alex and I like to put a lot of animations into this stuff. It works really well with networking to really stack up designs. Feel free to take a photo when there's a photo icon, and we'll try and pause for a second there. Otherwise, you'll be taking 5 different photos throughout the builds. And we have a couple of QR codes. Feel free to take a photo as well. There will be this session hosted on YouTube. It's pretty soon after we finish presenting. Hi, everyone online. The QR codes are there for you to grab in case you don't grab a photo. And lastly, we have this little wizard guy. He might pop in occasionally with a couple of helpful hints. Okay, so let's start from the beginning. So this is an EC2 instance with a public IP. This is what EC2 used to look like way back in the day. You'd basically get an instance, and it had a public IP, and you could reach that instance, and you could control the access, but you didn't get control of routing and other mechanisms that you used to get in on-premises deployments. So we built this thing called VPC, or Virtual Private Cloud. Virtual Private Cloud basically gave you the ability to then have subnets and deploy in multiple availability zones. And some of those subnets could be public or private, and you could do a whole bunch of stuff within the VPC. And then we deployed this thing called an internet gateway, which gave you internet access. So routing really became one of the key pieces to VPC to control traffic that basically goes to and from your instances. And so here we've got public services that are outside of the VPC, and we have a lot of services that are EC2 based that sit inside of the VPC. You might have a private subnet with a NAT gateway talking to the public internet or public services. We also have this thing called gateway endpoints where you could talk to S3 and DynamoDB. And so within the VPC, we started deploying all of these other services too, like our load balancing solutions, maybe AWS Network Firewall. But VPC really comes into its own when we start connecting things to VPC. And so you can connect multiple VPCs together. We'll talk about VPC architectures. You can use VPN, Direct Connect to connect on premises. And we realized that scale was one of the big things that our customers were asking for too. So in 2018, we released Transit Gateway. Transit Gateway allows you to connect up to 5,000 VPCs. You can connect to on-premises via Transit Gateway and to other transit gateways inside the region and inter-region, which we'll talk about in a second. We have VPC flow logs. We're almost ready for the build for photos. Private link, so you can have public services in the VPC privately, and you can build your own services and drop those into the VPC privately. Gateway load balancer, so you could build in things like an inspection VPC with a scalable firewall edge. Client VPN, and AWS Outpost, which extends the VPC on premises now. And so we've got that little build icon. Feel free to take a photo of this one. All right. If you didn't catch it, it will be on YouTube. I've got to move fast. We've got a lot of content. Okay, so globally, you can also connect VPCs across our regions, as well as Transit Gateway. You can peer Transit Gateways. Then last year, and actually this year is now generally available, we can do AWS Cloud WAN. So instead of controlling and configuring Transit Gateways, you can now use Cloud WAN to configure network segments. Oops, let me go back for that one. And so now you can connect all of these regions together using these different connectivity mechanisms. Okay, so that was the baseline. Now let's talk about the updates that we've done over the last 12 months. Okay, we'll start with IPv6. So I'm cheating a little bit here. We'll talk about 2021's IPv6 first, but V4 exhaustion is one of the reasons why folks are thinking about IPv6. It's always been the case, and the world is running out of public V4 addresses. That's nothing that's a surprise to anyone. But what was actually surprising to me and some of the folks here was our customers are running out of internal RFC 1918 addresses, so private IPv4 addresses. And what that means is folks are deploying that many VPCs and connecting to on-premises that they're running out of the 10 range, for example. And so V6 really comes into play when we start running out of public addresses, but also private addresses too. So in 2021, we released IPv6 only subnets. And so what that means is you don't burn a v4 address when you deploy a v6 subnet now. So you can deploy just a v6 subnet, which is pretty awesome. We also understand that not all of our services support v6. And so we released DNS 6-4. So when a v6 only instance does a lookup on a v4 address, DNS 6-4 will append a v6 address to a v4 address. And then we can use NAT 6-4 to route traffic to a NAT gateway and talk to v4 addresses. So now you've got this backwards compatibility through NAT gateway to talk v6 to v4. We also have ALB v6 targets. And so in this case, the targets or the area that's scaling where you need a lot of IP addresses can be only v6. Now we also have that for NLB as well. So ALB and NLB v6 targets. Okay, let's talk about some of our 2022 updates. Well, what we've basically been doing with V6 is looking at all of the services that we need to support them and doing the work that we need. So in 2021, we supported around 15 services. In 2022, we now support about 27 services. And so the idea here is we want folks to be able to use all of our services natively with V6. Now, I'll talk about Excel spreadsheets later and tracking of IPs, but I had an Excel spreadsheet where I was tracking services and what was V6 capable or not. You don't need to do that anymore. So we've actually got one of our documentation pages now that's available. Here's a quick QR code. And so you can just jump to this QR code and see, hey, does the service I want to use support V6? And we've got a couple of different columns there for different types of V6 support. Okay, and lastly, we have a centralized site where all of our V6, what's new, and blog posts and everything else now exists. So definitely check that one out. Okay. So let's move along here and talk about an update to EC2 instances called ENA Express. So basically, when we look at traditional TCP routing through a network is basically flow-based. And so when you have a TCP flow or a 5-tuple, it will take a particular path through our network. And so if you have different flows, sometimes they can get flow hashed to the same device. And what that generally means is you could have a device that is running a little bit hot compared to the others. So what we've actually done is we've taken our scalable, reliable datagram and implemented that into our Nitro system. And what that does is then use flowlets, and it's basically an Ethernet-based type protocol, and we spread traffic across our whole network. Now, you folks don't really need to do anything except tick a checkbox for the particular instances that support this, and then you can actually have improved network performance. And so basically, this is transport protocol independent, where you folks don't need to say, hey, I'm not going to use TCP anymore. You just use TCP or UDP, that's fine. But then you can get 25 gig flows. So traditionally, we only allow 5 gigabit per second flows through our network to prevent any overrun of traffic and that sort of thing. But with ENA Express, you can now get 25 gig, and it's within the same availability zone between two instances. So still 5 gigabits per second when you're talking to the public internet. A couple of considerations here. You don't need to do any changes after you've enabled this. It's enabled for Nitro-based instances. And again, it's just for traffic between EC2 instances. Okay. Quick recap here on the 25 gig, but it also does reduce some of the tail end latency for traffic, just because it's a far more efficient protocol for sending traffic over our network. So we see a 50% lower P99 latency for traffic going over our network, which is actually pretty awesome for folks that are doing things like streaming. And a quick QR code here for anyone who's interested in learning more about ENA Express. Okay. So this is advanced VPC design, so we absolutely have to talk about VPC architectures. And so one of the things that we think about with VPC architectures is VPC size, and how do we, AWS and you as a consequence, define VPC size. Now, this is from a network-wise perspective, and so what really constitutes how large a VPC is. Well, if we have a single VPC, right now today, and this is as of October 3rd, we can support 256,000 in-use IPs in a VPC. Now you might say, well, hold on a second. A /16, which I normally spin up my VPC and assign a /16, it's generally not a good idea to do that. Maybe something smaller than a /16 is a better idea. But you can have a /16 with 65,000 IPs or up to 50 /16s for a single VPC. That's 3.2 million available IPs. That's actually allocated IPs. So that's the VPC size from an allocated IP perspective. This is in-use IPs, IPs that are actually assigned to instances. And so previously, we'd ask customers to stay around 50,000 in-use IPs in a VPC. Now you can do 256,000, which is a huge amount. And so basically, this is a single VPC size. So if you have multiple VPCs, they're all 256,000. With peering, however, there is one side effect here. If you peer two VPCs together, we used to also ask that a peered group of VPCs stayed around 50,000 IPs, but now we ask you to, or there's actually a limit here of 512,000 IPs. Now the reason why those two are related is when you peer two VPCs together, they're closely related and you can do things like security group referencing. And so that means they become the same limit domain from a VPC size perspective or a in-use IP perspective. Okay, so some customers are building things like a VPC peering mesh. You might wonder how the effect is there. Basically, we count the IPs across VPCs that appeared, and we actually have two metrics that you can look at CloudWatch now. One is single VPC size and peered group VPC size, and you can see as we peer the IPs together here, the counts actually increase. And so it's an additive effect. Now, if you peered in a full mesh, it's an additive effect across all of those VPCs, and that peered group size increases. Now you might wonder, what about VPC sharing? VPC sharing has actually become very popular in recent times, so having a single VPC in an account and sharing that VPC to other accounts for folks to use so other folks can participate in that VPC. With that, the VPC across multiple accounts is still really in one account, so that's still really the same limits as before, and it's 256,000 IPs for single VPC and 512 for peered VPC as well. Now, as far as designing an AWS infrastructure, we've started calling this single VPC design vertical scaling of VPCs, just like with instances. So you increase the size of a single entity, just like you would increase the size of a single instance. What we would also recommend is to do vertical scaling, sure, and you can go much higher now than you could previously, but horizontal scaling of VPCs, so having many VPCs is also a good idea as well. And so this is where I'll hand it over to Alex to talk about scaling out with your VPCs.
Thank you. So we're scaling up. We're not just growing inside one VPC or a peered group of VPCs, but we are also increasing the number of our VPCs. And at small scale, VPC peering works well. Right? It is a non-transitive connectivity construct, so you need to start creating VPC peers between your VPCs that you want to talk to each other, which has the potential of becoming pretty crowded. Some of the use cases for VPC peering, which doesn't go away, right, with the addition of new connectivity constructs, is high throughput connectivity, low latency, and the minimization of data transfer costs, right? You know that inside the same availability zone across VPC peering, the cost is 0 for data transfer. As I was saying, this is becoming pretty crowded. If we increase the number of VPCs that we deploy, VPC peering is no longer scalable. So we have to make a decision of when we use VPC peering and when we go towards more scalable connectivity constructs, in this case, Transit Gateway. And we're going to start with Transit Gateway, and we're going to slowly get into Cloud WAN to see what the differences are there. Transit Gateway is this scalable connectivity construct, not just from the number of VPCs that it can connect to it, but also from the network address usage perspective. So when you connect VPCs to the Transit Gateway, the addition is no longer there, right, as it is with VPC peering. This being said, you can actually have a lot of VPCs that connect to the Transit Gateway in a scalable fashion. Some of the use cases for using Transit Gateway, which again do not cancel the use cases for VPC peering, is connecting VPCs across multiple accounts. So you can share the transit gateway through Resource Access Manager and have multiple accounts in your organization use it. Works with VPC sharing as well. So the VPCs that you connect to the transit gateway can be shared VPCs. VPC peering is also supported because we're talking about the different types of routing, so more specific routing in between VPCs, longest match, right? And a more encompassing route to the transit gateway. And allows you to create network segments, right? So you see that the colors change there. When you peer VPCs together, there's no segmentation, right? You put everything together in that peering group. With Transit Gateway, you can create multiple route tables, and with that, you can segment your network. Let's look a bit at the segmentation piece. And here's an example of the routing detail of how you configure the Transit Gateway with a routing domain for each of your use cases. Here we have 3 route tables. When you create the attachments to the Transit Gateway, each VPC has its own attachment, which is associated with the route table. Then you can decide where to propagate that attachment. So the association with the route table and the propagation of the VPC CIDR to one or more route tables are 2 independent constructs on Transit Gateway. You can choose to propagate the CIDRs of VPCs across multiple route tables if that's the use case. And last but not least, each VPC route table also has to have the route or routes or set of routes pointing to the Transit Gateway, right? Now, we're growing, right? We're scaling out. We're adding more regions. With Transit Gateway, you have the ability of creating cross-region peering connections. The only downside for that is that you need to add static routes in the route tables of the Transit Gateway. So the question comes, how can we make this simpler? How can we have the routing in a dynamic fashion? And also not needing to, when we expand towards multiple regions beyond just 2, how do we not start managing all those peering connections between transit gateways? And here is where Cloud WAN helps. Cloud WAN is based on the transit gateway construct, so it allows the same as transit gateway to aggregate hybrid connectivity at scale. You can do this with transit gateway, and you will also be able to do it with Cloud WAN. And it allows also integration of visibility, right? So there is the need for enterprises who have office locations and data center locations with SD-WAN connectivity to integrate those appliances. The way this integrates, and is the same construct here as we'll see for Cloud WAN, is through the Transit Gateway Connect attachment, or Cloud WAN Connect. To be able to create that Connect attachment, you have to specify a transport attachment for the Connect attachment. The transport attachment can be twofold. It can be a VPC attachment or a Direct Connect Gateway attachment. Once you've created the transport attachment, you can then create the Connect attachment, which is the one that enables you afterwards to define the Connect peers. The Connect peers are the BGP sessions with the appliances that you have either in a VPC or on your on-prem. They are the GRE tunnels that you can create up to 4 on each Connect attachment. And they allow you to dynamically route and advertise routes on the SD-WAN infrastructure. Now, we're scaling, right? We don't want to start managing transit gateways in every single region beyond the initial setup that we had. So here's where Cloud WAN comes into play. Imagine that you have your global network that has multiple AWS regions, multiple data centers, multiple offices. Connecting this at scale requires a lot of network knowledge, right? It requires knowing a lot of BGP, or would have required, actually. And we're here to make it easy, right? We're here to help you build that global network. With Cloud WAN, you can use the AWS Global Backbone for that global network connectivity. It simplifies the WAN deployments. Everything is managed through a centralized policy in Cloud WAN. And it allows you to centralize traffic segmentation, right, across multiple regions. We will see that when you define the Cloud WAN segments, those are global segments. So before we go into the architectures for Cloud WAN, let's look at the components, right? It's very important to know the terminology first. We have the core network, which is our global network on AWS. We have the core network policy, which governs the connectivity regions where Cloud WAN is present and route advertisements. We have the core network edge, which is the under-the-hood routing component in Cloud WAN, right, to which all attachments are connected. And we have segments. On Transit Gateway, we had route tables. On Cloud WAN, we have segments. The segments can be defined as global, right? So you can say, I have my production segment, and my production segment lives in 17 AWS regions, right? And last but not least, we have the attachments. So the attachments, the same way as with Transit Gateway, can be VPC attachments, VPN attachments, Connect attachments, and we'll see how the integration with Transit Gateway looks like. How it works. First and foremost, you create the global core network, right? Second, you need to define the policy. You need to specify in that policy where are the regions where you want to deploy, and AWS will take care of connecting those regions together. You do not need to create peering connections anymore between regions, and it will also take care of dynamically advertising the routes between regions, right? So keeping that end-to-end segmentation. And you also need to define what happens when you attach different objects to Cloud WAN. What happens with those attachments? So when you define the segments in Cloud WAN, these segments, you choose what regions they need to be in, and you define the policies. What a policy says is essentially, how do I, Cloud WAN, dynamically map an attachment to a segment so that you, as an admin, don't need to manually go there and attach them and propagate them. So based on the policy, you can match different conditions in the policy. I've chosen here to put the environment, the tag environment, and the value is prod dev stage, or red, green, blue. And once the attachments from different constructs like VPCs or VPNs get created with the appropriate tag, they get automatically attached and propagated to the right segment, right? This happens with all the segments that we define in Cloud WAN. Also, because I mentioned that we're going global, right, and we have a global network that we need to manage, you can centralize hybrid connectivity, allowing you to have full dynamic routing between all your components in the infrastructure and the different domains, right? To be able to have this, we need the integration with Transit Gateway, right? So let's look at a deployment detail with a region where we have one Transit Gateway, and we need to peer this Transit Gateway with Cloud WAN. The peering connection is just a transport, the same way as the transport attachment was defined for the Connect attachment. Once we have the peering connection established, the route tables on the Transit Gateway can be expanded into the segments in Cloud WAN. And this expansion preserves the end-to-end segmentation, right? So there is no crossing between route tables on Transit Gateway and Cloud WAN segments. Very important, once we've done this, the routes that Transit Gateway knows in a route table and the routes that Cloud WAN knows in a route table get automatically propagated between the two. So you don't need to go into TGW and configure static routes. You don't need to go into Cloud WAN and configure static routes for the TGW attachments. With this, here are some considerations to keep in mind when you're peering Transit Gateway and Cloud WAN together, right? Very important that the peering connection is just the transport, and then you have to create the route table attachments, right? All the other ones that subside from that. Now, we've talked about the pure networking and connectivity piece, right? We've scaled out our network. And if we look at Matt last year, he was very excited to show you all the network connectivity and VPC constructs here, but he's a wizard, right? And most of the times developers are not really wizards, and they shouldn't be in networking, right? They're wizards in their development world. Security as well, right? Security wants to enforce security policies to make sure that the environment is deployed appropriately. But most of the times, all these three personas kind of clash, and they all want to do the best for the application, but they also come with requirements. So you may say from the perspective of connectivity and application deployment that service meshes could help, right? We've all probably heard about Istio and all the other flavors out there. Well, there's some challenges with service meshes. The first one is they usually require a sidecar proxy that you need to manage. And you need to manage at scale. And here's where the network and the application folks come together, and they're like, the network people say, well, why should I manage proxies at scale? Like, I don't want to be in the business of managing proxies. Then the second one is it works, the service meshes work very well with container-based workloads. But what if the environment is not 100% containers? You may have different compute platforms. You use Lambda functions. You may use ECS or any other, or EC2 even, right? How do you integrate those workloads into the service mesh? And last but not least, network connectivity is still required. So you still need the network folks to come in and say, okay, we're going to do VPC peering here, and we're going to put transit gateway here, and you need to configure the route tables and all of that. And it's not easy, right? It's a complexity that we wanted to take out from the space. And we're going to talk a bit about VPC Lattice. We've gotten a lot of questions this week about this new product, so we're very happy to actually have it in our presentation. What are the components? First and foremost, before we dive into some architectures, the service network, the services, right? Service directory, and security policies. If you look at these components, they actually relate to every single one of those personas that we mentioned at the beginning, right? We have the network persona, we have the developer persona, and we have the security persona. So they all three have the necessary leverage points in configuring Lattice to meet their needs, right? Let's look at how it simplifies application layer networking. First and foremost, there's no sidecar proxy required. Lattice does everything. Second, it works across different compute options. So you can have Lambda functions, you can have EC2, you can have EKS workloads. Third, you have enhanced traffic controls. So the application owner persona is extremely happy with all the layer 7 application controls like weighted target groups or path-based routing and so on. And last but not least, does not require connectivity expertise, right? So you can deploy it, you can start deploying it without needing to actually configure transit gateways and VPC peering under the hood, right? Again, VPC Lattice takes care of it. Let's see how it works. And we've talked about the three personas, right? We're going to see them here in the how it works flow. First, we create the service network. The service network is that logical construct that brings together services and consumers, right? This service network can live in an account, usually in the network account, And it can be shared with multiple accounts in the organization because we're not talking about a single account deployment. We will see that we also have a different sharing model where services can be shared if we don't want to share the service network. But the important thing here is that the sharing is a RAM construct, again, so all the sharing possibilities that you are already acquainted with work as well. Now, we've created the service network, we've shared it. The third thing, we need to attach VPCs to the service network. When we attach VPCs to the service network, we essentially enable application networking for these VPCs so that services in these VPCs are able to start consuming other services that are registered in the service network. We'll get there to the registration part. But this is essentially opening the path, right, to application networking. When this attachment gets created, you have the ability of associating a security group to it. Very important, the attachment is not an ENI in your VPC. The attachment is not in the user space. It works in the 169.254 IP address space, so it doesn't consume IP addresses from your VPC siders, right? Therefore, it is not an ENI in your VPC. You folks may be familiar with the 169.254 space from the on-instance instance metadata services, NTP, and so on. It is the same big IP space that we're using. With this security group, you can control who gets access to Amazon VPC Lattice. From the developer's perspective, we have services. Developers don't and shouldn't, at the end of the day, care about boundaries related to VPC, because those are network boundaries, right? Or account. Security cares about account boundaries, right? And they are usually saying, okay, let's split workloads into different accounts. But from the developer perspective, what they need to do is define services in Lattice. Those services are very similar to listeners on application load balancer that you're already accustomed to. Once you've defined the services, these services get created in Amazon VPC Lattice, so Lattice knows about them. That service directory gets populated, right? Once we've defined services, we need to define routing policies. Again, developer actions, right? We need to know, well, do we want to do weighted target groups? This is a useful situation when, for example, we need to migrate. And we want to migrate from EC2 maybe to EKS, right? And we don't want to do a major blast impact button switch type of migration. We want to do blue-green deployments. Or you can configure path-based routing, and you can have an application that accepts multiple paths. Again, developer persona. All networking folks in the room are like, okay, they do it. We don't have to do it for them. That's awesome. And the third thing is, once we've created the services, we register them to the service network. Registering a service to the service network means essentially giving access to that service in the service network. So enabling consumers to consume the service. Every service, when we register it to the service network, gets a DNS name, which gets resolved by consumers in the VPC to a 169.254 IP address. And here is a very important thing. Given the fact that a consumer gets a 169.254 IP address for its service, this means that Amazon VPC Lattice is completely not interfering with existing connectivity. Existing connectivity, VPC peering, transit gateway, Cloud WAN, and so on. They route 10/8, 172.16, and so on. They don't route 169.254, right? You don't need to change route tables to have access to 169.254 because it's outside of your user space, right? So you've registered services, you get DNS names, and communication works. Now, last but not least, there come security folks in the room, and they're like, oh, well, how do I manage security? You have two places where security can be managed. At the service network level, you have authentication and authorization policies, and at the service level. So you can grow as granular or as coarse as needed in these 2 points to actually meet security requirements. The policies are IAM, so you can do everything that you can do with IAM, you can do in Lattice. Last but not least comes monitoring. And there's a very big question that we always get from customers: how do we understand our service dependencies, right? How do we know which service needs to talk to which other service? Well, you have target group metrics, you have service metrics, you have access logs, both at the service level and at the service network level. These can be exported to either S3 or Kinesis. And you also have CloudTrail integration. So you see everything there. If we put everything together, we've created a service network. We've attached VPCs to the service network, enabling clients to consume services in the service network. We've defined services. We've registered them to the service network, enabling them to be consumed. And we have policies. One thing important here is that you see that a service can be part or can be consumed in multiple service networks. You see that also one VPC is attached to one service network at a time. Some considerations: you don't need to manage additional network configurations, accommodates for the existing one, accommodates for overlapping IP addresses, so those VPCs where services live, they can have all overlapping IP addresses. One VPC can be attached to one service network at a time, and one service can be registered to multiple service networks. Scan the QR code for more detailed information, and please subscribe on our website if you want to get access to Amazon VPC Lattice. Now, coming back into the network world a bit, one of the reasons for which network operations essentially is very important is because it gives us visibility and it gives us observability, and it helps us understand where should we look to troubleshoot, to improve, to plan our network. Starting from our global network, right, with a lot of AWS regions and data centers and remote offices, it seems fairly complex to manage everything and to have observability into everything. Well, AWS Network Manager now has a new face. It brings together everything that means network operations in one place, right? So you can manage in Network Manager your transit gateways, your Cloud WAN connectivity, IPAM, network performance insights, network monitoring, and all the tools that you have to actually create that network operations center, right? Let's look a bit more in depth in what Network Manager brings. And we have here Reachability Analyzer, we have Network Access Analyzer, we have IPAM, we have Cloud WAN, and we have Infrastructure Performance. This seems new, right? If you folks are familiar with Network Manager. It is new. For the first time, we are publishing the AWS monitoring and observability data for the AWS Global Backbone. So you subscribe to CloudWatch metrics, and you're able to monitor your latency inside the same AZ, cross AZ, and cross regions. You're able to understand the health of your environment, understanding if there's an impairment in one part of your network, and you're able to plan your growth. It's very important to understand that business-driven goals, right, impact network connectivity and network design, right? So deciding to adopt new regions or to expand across different regions means also understanding how that network connectivity will work, right? And if latency between your regions and your newly adopted locations is going to be acceptable from the application perspective or not. Here's how the subscription to the metrics looks like. You simply go into infrastructure performance. You can filter by regions, source regions, destination regions. And once you have selected the metrics, you will see a graph with the average performance latency metrics. You can do this inter-region. You can do inter-AZ, so you can choose one AZ as a source and the other AZs as a destination inside the same region. So you will see the average data here. And you can see also inside the same availability zone. And because monitoring is important, we've looked at monitoring on the AWS backbone. We also need to look at monitoring for our public exposed endpoints, right? And historically, because of the size of the AWS backbone and the presence, the global presence, we have had the data related to the internet weather, right? We know what is the internet state in every single location where we are. And customers have asked us to facilitate them troubleshooting their public-facing endpoints exposed on AWS by using that data. So CloudWatch Internet Monitoring allows you to monitor resources in VPCs, CloudFront distributions, or Amazon Workspace directories. So when you define a monitor, you select the resources you want to monitor. Once you monitor them, you can start tracking real-time performance, right, and availability for your endpoints, which is an extremely powerful piece of information to understand the user experience related to your endpoints, right? You may see everything healthy related to your, I don't know, CloudFront distribution, but if something in the internet weather is not right, your end users may have a very bad day and experience. Then you can explore historical data. You can understand what your user base adapts and how it grows or it shrinks in different regions and geographies, because you see the amount of traffic that's coming from each of the geographies and the accumulation of users. And you can optimize. This is probably one of the most important ones, because once you see the data, the question comes in, well, what can I do about it, right? I see that the internet has a very bad time in a certain region. How can I optimize the user experience in that region? So you will see insights related to how the time to first byte, for example, is compared to your endpoint exposure and the exposure through CloudFront, right? And you can make that decision of making the change. One thing that's very important is related to the metrics that you create. You can alarm based on them. So you will know at every point, depending on how you configured your alarms, what is the state of your endpoints. Here's some graphs related to a monitor example. So we've chosen here to create a monitor for a resource in a VPC, and we have the health score for that monitor. We also have a map, world map with our user base, and we understand where users located for our application are. And we can also understand what is the traffic health score and how the health events that are generated by Internet Monitor look like. If you folks have more questions, scan the QR code, and Matt, take it from here.
Thanks. What an entrance. Thanks, Alex. So that was a lot.
That was a lot.
We're not done yet, though, so we still have one more here. Verified access, or what we've actually been calling AVA. So verified access, let's talk about the setup here. So virtual private cloud and security, they both go hand in hand. When you think about having an isolated environment where you control everything, it can also be a secure environment. We've also built a whole bunch of networking/security-based features over the years, things like security groups and NACLs, day one baseline stuff. NAT gateway is obviously a routing function. I wouldn't call it a security function, but it can be used to control who can reach instances inside your VPC. Network firewall, we've been doing a whole bunch of encryption at a VPC layer that you don't have to worry about, within the VPC itself. AWS Shield for DDoS, WAF, DNS firewall, partner appliances with gateway load balancer. There's a whole bunch of stuff we've been doing. But there's one thing that comes to mind when you think about a VPC. It's really a walled garden. If you're inside the VPC, apart from security groups and NACLs, you kind of have routing access to things within that environment. And so zero trust is something that can mean a lot of things, and there's a whole bunch of documentation and stuff around zero trust out in the public realm right now. But the key thing that I've taken away from zero trust is really that wherever you are in the network doesn't mean you have that security policy applied to yourself. So your location in the network shouldn't dictate your security. Now, if we look at traditional means of extending a VPC, like client VPN or site-to-site VPN, what you're effectively doing is you're taking your VPC and from a routed perspective, extending that to your on-premises. So now things that are on-premises can say route to applications that are in that VPC. Now, you might be using something like site-to-site VPN with Transit Gateway. The problem grows even further because a Transit Gateway can have up to 5,000 VPCs attached to it. So now you've got one site-to-site VPN connection and 5,000 VPCs. Now you've extended your walled garden quite far. You might also use Direct Connect. So now you've got a physical fiber, you're going through one of our AWS Direct Connect POP locations, and you've got a high performance connection into the VPC directly. Direct Connect Gateway expands up to, I think it's like 10 VPCs, or Transit Gateway, again, 5,000 VPCs for a physical connection coming into AWS. So security groups and NACLs are really what we're seeing out there, where folks are saying, hey, I've got a subnet, I've got an instance, I'm going to put a security group in a network ACL. Folks are doing the same thing with their on-premises routers too. You've got a Cisco router or Juniper router or some appliance router there, and you're actually doing NACLs on that to say, hey, I only want you to be able to talk to these destinations. It can become quite cumbersome. So this week we released AWS Verified Access. And so the idea behind this is we want to be able to improve security posture beyond just security groups and NACLs. So things like evaluating users as they come in and what policy and what applications they have access to. We want to simplify operations, so you don't have to remember what your destination IPs are for your applications every time you want to lock down security. And lastly, increase workforce mobility. So basically having users be able to use a browser to come in and access an application inside AWS. So before we quite get to verified access, I just want to set things on the same scene in this isometric kind of style. With VPN, basically, you're extending your cloud deployment to your users. There's a few different areas that you can manage policy, but it can get complex. So first, we've got VPN policies, right, for the VPN itself. You might have some identity-based policy on your applications. You might also have some device-based policies for your users. So you've got 3 different areas now where you need to manage that access as well. Now, with verified access, it basically looks like this, where we're front-ending our cloud deployment with AWS Verified Access. So you're coming in through Verified Access, and you can manage a per-app policy at that central location. You can see access records, so you've got observability there as well. Your applications on the back end of Verified Access are in your VPCs, just like they were before. But what you're doing now is associating those applications with Verified Access. We saw it with Lattice, and we've seen it before with things like an ALB. An ALB has targets, and that ALB is kind of the front end for your application. I think Lattice, by the way, is an amazing service, and I'm super excited to be playing around with it over the next couple of weeks over my Christmas break. Verified Access is using a similar kind of mechanism to say, hey, let's take this application and associate it with this service, this Verified Access. Now, on the side here, you can see that we're integrating with trust providers for things like IDP, EDM, and others. So we've got trust providers that work directly with Verified Access, and that's a big part of the story around Verified Access. And so our integration with trust providers, basically we've got contextual and data partners, IDP partners, device security partners. We've integrated with SIEM and observability partners. And lastly, I think, which was an interesting one, network management partners like Prosimo. And so at launch, we've got a set of partners that we've integrated with, folks that you use, like Okta and Jamf. And Datadog. These are partners that folks are using today, so it's nothing new. Now, I'm hoping this list grows over the next couple of months, and we integrate with many more partners. So I'm super excited to see how that goes. And lastly, we have a link here, a QR code, if you'd like to learn more about verified access. So that brings us to the end of advanced VPC design and new capabilities for Amazon VPC. Thanks everyone for coming along today. Please do fill out the survey. Write any comments and suggestions in the survey comments. We actually read every single one. Sometimes I ask people to put jokes in there, but some of them were funny.
It helps us improve.
It helps us improve. The camera icon was actually a couple of years ago. Someone said, hey, why don't you put a camera icon at the end of the build? So that was a great suggestion. So please post them in there. We love 5.0s too.
Yep, for sure.
CSAT. Okay, so I'm Matt Lewis. Thanks very much.
I'm Alex. Thank you so much for coming.
See you next year.